Hi everyone, my name is Iikka. That's 2 I's, 2 K's, and an A. Don't worry if you get it wrong, because everybody does. I work for a company called Relex, or Relex, depending on who you ask. We're based in Helsinki, Finland, with a total of about 500 employees at the moment. Most of the people work in the Helsinki office, but we also have sales offices basically everywhere in Europe, as well as in the US, and another development site near Manchester in England. What we do at Relex, we've branded as Unified Retail Planning. Basically, that means that we use a lot of data and hardcore number crunching to make things better for retailers and their customers. We do things like less out-of-stock situations, less things to throw away, less stuff sitting in warehouses, better layouts in stores, better assortments in stores, and better workforce shifts for the workers. We achieved some quite amazing numbers, as you can see, with 85% out-of-stock reductions, 30% lower inventories, and 40% waste reduction. That last number is a really nice one because it means we're making the world a better place by throwing less stuff in the trash. And how do we achieve those amazing numbers? Well, basically every night after a client closes for the day, we receive for all their stores and warehouses all the sales transaction data and all the balance data for the previous day. Comes directly from their ERP system, which is populated by their point of sale systems. Using that data and historical sales data for many years, weather forecasts, and all the other things you can imagine, we calculate demand forecasts for each and every product in each and every store and warehouse for the customer. After we have forecasted the demand, using that knowledge as well as existing stock data and a fully customizable ordering strategy, we calculate ready-to-use order proposals for the customer. So we calculate exactly how many liters of milk they need to order from their suppliers to each store so they don't run out of it, but they don't get any wastage either. We then send those order proposals back to their ERP system and they deliver them there to their suppliers. We typically have some hours in the morning to do this calculation. For example, we might receive the data at 1 a.m. in the morning, and we have until 6 a.m. in the morning to have the order proposals sent back to the customer's ERP system. We also use the same forecast data to optimize other things, such as store space, the assortment in the stores, the workforce shifts, and many other things. For the core forecasting, planning, and order proposal calculation platform, we've implemented a completely custom in-house, in-memory data platform. It's implemented as a single Java virtual machine where all the algorithms, all the rules in the business logic, the API layer, and even our own proprietary columnar in-memory database run in the same process. There's one separate installation of this process per customer, and it's not distributed in any way. Our software usage patterns are very data intensive. It's really the data access that dominates all the calculation time. The actual computation time of the algorithms takes comparatively little time. So this kind of approach maximizes the throughput throughout our stack. The database access can be as fast as local memory access. This allows us to encode data in memory in the most optimal order, guaranteeing sequentiality and very good compression. To give you some idea about the numbers involved, we recently ran a performance demo where the goal was to forecast 100 million SKUs, which means combinations of products and stores, for 60 weeks into the future. We did this in 2 hours, creating 42 billion new forecast rows. But even though we achieved some amazing performance and amazing customer satisfaction with technology like this, it's obviously not limitless. What do you do when you can't buy a bigger server to host an even bigger customer? So some kind of scale-out approach might be needed. On the deployment side, we'll run on bare metal in co-location spaces. Each customer, as mentioned, runs a separate installation, single tenant, is assigned to a specific server. The amounts per server depends on the customer sizes. Largest customers typically get their own wholly dedicated servers. Each server is basically an isolated island. The persisted data from the system only exists on the local disks of that server, except for backups. So you can imagine if there's a hardware failure on one of the servers, that's going to be a huge scramble for the operations team to find available capacity on other servers and then restore the installations from cold backups. It also makes other kinds of capacity management really hard. When an installation outgrows the space it was allocated before, then you need to find space on another server and manually move everything over there. I'm sure you can see some other problems with this kind of approach as well. So I think we've identified 3 pressing issues with the current megalithic architecture. The maximum installation size is limited to a single server. That potentially limits the maximum client size. It also limits the reliability of a single installation to a single server. And it makes operations work harder since you need to move the persisted data around if you want to move installations. Well, there's one obvious solution. How can you keep the amazing performance of our embedded solution while getting some solution to these issues? That's, of course, adding distributed features to the existing data platform. And that is exactly what we've been doing for the past couple of years. In any case, you need to start somewhere. So we decided to focus on numbers 2 and 3 and at the same time gain replication for our database by externalizing the storage layer into a distributed scale-out storage system. There's an interesting implementation detail of our in-memory database. Each transaction is committed as a new file that only contains the changes from that transaction. For any previous data, it just links to the previous commit files on disk. So in other words, it's an append-only log of changes where to get the current state of the database loaded from disk, you start from the newest file and load until you reach no more links. Or in one more way, it's an ever-growing list of immutable files that reference each other. And as long as you know the name of the first one, you can find all of them, all the ones you need, which makes it very usable, suitable for object storage. Since we run on-prem and on bare metal, we can't just go to AWS and buy S3. So we started a project to find a suitable object storage partner. Unfortunately, there are a lot of object storage vendors out there. Our project documentation lists about 40 different vendors that we researched, approached, and spoke with. Our selection process was completely driven by the needs and hopes of the product development and the operations team, based on their technical needs and the cultural fit between our teams and the vendor's team. I was personally involved in basically all aspects of this project, from formalizing the specs to cold emailing vendors to sitting through tens of demos to the final contract negotiations. It took us about 6 months to narrow this list of 40 vendors down to a short list of 3. One of those 3 went bankrupt during the POC, and we got stuck with the trial servers they had shipped to our office. They're still sitting there and we can't do anything with them. With another one, even though their product is technically really amazing and the people are super talented, we just didn't feel that cultural fit. We just didn't feel that working with them was as easy as working with our own employees. So that really only left us with one choice: OpenIO. Here are some of the praise we used in our internal communication to qualify the choice of OpenIO. Great cultural fit. Working with the OpenIO guys from the get-go has been really easy, and their values match our company values quite well. They're prepared to answer stupid or deep or any kind of technical questions. They understand that we are a technology company and we are interested in the technologies we're on. So no matter how deep your question is, they are prepared to explain it to you. Well, the core parts are open source. That is always nice. Another thing that is always nice is to minimize vendor lock-in. Using the S3 API allows that, but even more importantly, I think it allows us to use standard SDKs in all our clients. One place where OpenIO basically outshone everybody else on the market is the capability to really scale from nothing to helabytes of data using any kind of hardware, mixing and matching hard drives, servers, architectures, whatever you want. And last, but definitely not least, we had some convincing discussions with OpenIO's existing customers who generally seemed really happy with OpenIO, but were not afraid to say when they felt that something could be better. I first emailed OpenIO around end of May 2016. And over the summer that year, we had good discussions on the phone, emails, some WebEx demos, stuff like that. And that culminated in a visit by Guillaume and Nicola in our Helsinki office in September 2016. That was very fruitful, and the guys followed up shortly with a POC proposal. As it happens, at the time, I was living in Barcelona. The OpenStack Summit happened to be in Barcelona, and OpenIO guys were visiting the summit. So I had a great night out with Guillaume and Marie that really helped build that personal trust that is so important in cases like this. So a couple of weeks later, we signed on for the POC. Early next year, I traveled to Paris for the first OpenIO meetup held at Dailymotion. Even though all the presentations were in French and I couldn't understand a word, luckily Thomas had made his slides in English, so I could follow along Dailymotion's rigorous process and quite good results. This really helped convince us further of OpenIO's technical capabilities. The BOC was installed shortly after that. Guillaume was again in Helsinki, this time with Sebastian. They installed it on site and gave some training and answered some deep technical questions as usual. In mid to late March, myself and 2 other colleagues from Relex went to visit OpenIO here in France to iron out any last concerns, meet some last-minute references. We left totally convinced, and by the end of the month we had an internal co-decision to go into production with OpenIO that we also had communicated to them. This is also where the most tedious part of the process for me starts, the contract negotiations. During the contract negotiations, we also worked on getting the first production cluster installed. That took much more time than you would think, but I guess that's typical when you're dealing with your own hardware, with things like missing cables and rack slides that rust and stuff like that. But by the end of summer, we had the contract signed by both parties after 5 months of tough negotiations and the first production cluster installed. A week later, I got a chance to celebrate this at the first OpenIO Summit, which was the greatest thing ever until today. Unfortunately, there were still a couple small issues with our production cluster, namely, even though it was humming along nicely, working perfectly, there was no way to monitor it, and getting that monitoring set up took a really long time due to various communication problems, mostly on our side, I think. So, all in all, OpenIO is going really strong at Relex. Like I said, it's in production in our primary data center in Finland for 1 year now. We are now in a process of ramping up a second data center in Finland where OpenIO will be installed from the get-go. These 2 data centers will be connected by a private 40 gigabit link, and that will be used for replicating between the OpenIO clusters. Once our hardware team gets the second data center in Finland up and running, they will move on to the US, where they will start ramping up a data center for US customers. This is hopefully done by February and will also be completely powered by OpenIO. So I don't see any end in sight to the OpenIO and Relex cooperation. Quite contrary, I think it will grow deeper and stronger. Thanks everyone, that was everything I had prepared for you.